Starship completes its 5th test flight. Europa Clipper launches successfully. China's science plans from now until 2050, and Jupiter's Jiggly Great Red Spot. All this and more in this week's Space Bites. Well, over the weekend, we had just an enormous amount of rocket launches and spaceflight. And of course, the one that everybody was focused on was the 5th test flight of SpaceX Starship and the Super Heavy booster. And you got to be living in a cave under a rock at this point if you weren't completely up to date on everything that happened with Super Heavy and Starship over the weekend. I'll just give you the quick rundown, and that is, of course, that the goal this time was to test Super Heavy and Starship and test to see whether Super Heavy could do a boost back burn, come back to Boca Chica, and be captured by this enormous launch gantry called Mechazilla. And the launch went perfectly. We saw the separation from Starship and the Super Heavy booster. The booster came back to the launch site and they caught it. It was crazy, amazing to see that this gigantic building-sized spacecraft was captured by an even larger launch gantry. And with the Super Heavy safely captured, Starship continued on its ballistic trajectory, re-entering the atmosphere above the Indian Ocean. We did see some damage to its flaps, but it was survivable, and it really landed with pinpoint accuracy in the ocean. And you could see that because there was a buoy in the ocean watching the landing spot, and you saw the spaceship sinking down into the ocean after the soft landing in the ocean, and then the explosion. But anyway, I'm sure you watched it live, you then watched the replay, you watched countless videos about what happened, reaction videos. Of course, we got in the action. I brought together my good friends Scott Manley and Marcus House, and we did an hour-long deep dive analysis of the mission, how well it went, what the plans are for the future. And so if you missed that, you should definitely check it out. But there has been a few updates that have come out since the successful test. So first, a big question is, when are they going to try to capture Starship in the way that they captured Super Heavy? And on X, Elon Musk replied to a comment and said, the plan is to try and capture Starship sometime in early 2025. So that's definitely planned, and we'll find out when they're actually going to try to implement that. A lot of people noticed that there was some damage to the grid fins during the hot staging, and I think this is going to be a concern that they're going to have to look into. And then, of course, as the rocket was doing its boost back burn, as it was coming through the atmosphere, the whole engine area got really heated up, and we saw some damage to a bunch of the nozzles. And according to Musk, they know what the problem is. They know what the solution is. He says it should be an easy fix. And so hopefully this problem will be solved for the next test that they do. And so once again, if you want that deep dive, definitely check out the conversation that I had with Scott Manley and Marcus House. But the other big launch that happened over the weekend was the Europa Clipper. And this is a mission from NASA that's going to Jupiter's moon, Europa. And I don't know if you know, but this is the heaviest interplanetary mission that's ever been launched by NASA. This thing weighs 6,000 kilograms. Of course, this required the heaviest lift rocket that's available right now, and that's the Falcon Heavy. And so the rocket launched in an expendable mode, which means that we didn't get to see all these cool landings of the boosters and the central stage. They had to use all that fuel to push Europa Clipper on the fastest trajectory that they could. Now, there's still some more work to be done. Europa Clipper has to be able to get even more speed boost by doing gravitational assist, going past Mars, and then it's going to go past Earth again in 2026. And we know that they successfully deployed the solar panels, and these are the largest solar panels that have ever been put on a spacecraft. The problem is that when you go out to Jupiter, you're receiving 1/25th the radiation from the sun that you get at Earth. Each one of these solar wings is 14 meters long. That's like 45 feet for people in Imperial Land. So this thing is enormous. What's that, like a tennis court? No, basketball court? They're big. Very big. Now, the goal is to understand this incredible icy moon at Jupiter. We can see from space that there are these huge cracks. It has this relatively unmarred surface that means that some process is resurfacing this moon. And it's believed that there is this thick ice sheet surrounding a giant ocean of liquid water. And of course, wherever we find water on Earth, we find life. And so the hope is that there could be life on Europa underneath the ice. But the big question is, how much ice? Is it a very thin shell or is it very thick? Are there pockets of warm water underneath the surface of the ice, or is it just this giant thick shell that goes all of the way from the top to the bottom? In addition to the standard suite of science instruments, Europa Clipper has a ground penetrating radar that will allow it to look down through the ice and actually be able to map out whatever underground lakes and chambers and cracks there is under the surface down to hopefully the top of the ocean. And so we'll know finally, once and for all, where the ice ends, where the ocean begins. Surrounding Jupiter is a large amount of dangerous radiation. And so the plan with Europa Clipper is that it's going to fly on this giant elliptical orbit around Europa. It's going to zip in, spend as little time as possible in the most dangerous part of the zone, take a bunch of pictures, do its data, and then fly back out. And this is the same thing that we see with Juno. Now, after that flyby of Mars and then of Earth, Europa Clipper is expected to arrive at Europa in 2030, and then the science begins. So we're still 6 years away from seeing those first close-up images of Europa from the Clipper. But of course, we'll keep you posted on various science that gets done along the way. The one that I always love as spacecraft do flybys of Earth is they try to figure out whether or not Earth is a habitable planet. They sort of take the definition of an exoplanet and then go, if we didn't know that Earth had life on it, would Europa Clipper find life on Earth? So I guess we'll find out. We'll discover whether or not Earth is a habitable planet. Again, seeing Uranus from both sides. Reminder, I will say Uranus in whatever way is the most hilarious. Every year, the Hubble Space Telescope takes pictures of all of the planets when they get to their closest point to Earth. And it's a way to just sort of track changes that are happening to these planets. And that includes Uranus. And so this year, we got new images of Uranus taken both by the Hubble Space Telescope, but then matched up with new images taken from the New Horizons spacecraft. Now, the images are not the same. Hubble was only 2.7 billion kilometers away from Uranus when the picture was taken, and Hubble is one of the best telescopes ever made. New Horizons was 10.5 billion kilometers away from Uranus and a relatively small but very good camera system designed to observe the surface of Pluto. So these two pictures are not the same. However, what this did was allowed astronomers to compare how images of an ice giant planet compare from something like Hubble compared to something where it's a lot farther away with a smaller telescope. And this is giving us insights into what it will be like to observe these kinds of worlds as exoplanets. And so you can sort of imagine, you know what it looks like at this distance with this set of optics, you know what it looks like at that distance with that set of optics, and it gives you some ideas. And so one interesting insight that astronomers had was they found that the phase of the planet actually has a very big impact on what you can see. Now, obviously, when we can see a thin crescent moon compared to the full moon, but it really changes the brightness of the world, and it could actually introduce some errors into what you think you're seeing. And so this is a form of calibration, and I really like the idea. And so we can imagine more of these collaborations between different spacecraft looking at the same object at the same time to give different points of view that then scientists can use as they imagine what would be possible to see exoplanets. China's science plans to 2050. We do a lot of coverage about what's happening with NASA and Europe, but we also talk quite a bit about what China's plans are for space exploration. And although a lot of the details of China's space plans are fairly secretive, we do know the large timeline of what they're planning. And recently they put out a new document that charted their entire plans for space science from now until 2050. So it breaks up into 5 major scientific themes. They've got the extreme universe, which sort of deals with the origin and the evolution of the universe over time, what they call space-time ripples, which ideally is space-based gravitational wave astronomy, panorama of the Earth and Sun, and that's understanding the environment between the Earth and the Sun, the interactions, the solar wind, coronal mass ejections, things like that. Habitable planets, and that's examining the role of habitable planets both here in the solar system as well as exoplanets. And then biological and physical space science. And this is sort of thinking about what are the implications of humans and other life forms in space. What does being in space do to biology? And so they also provide what kinds of missions we should expect to see in the coming years. For the next 3 years, it's very detailed. We know that they're going to be continuing to operate their Tiangong space station. They're going to be launching their Chang'e 7 and Chang'e 8, which are going to be 2 more missions to the moon. And then between 2028 and 2035, they're planning on expanding the Tiangong station to twice its current size. They're going to be sending crewed missions to the surface of the moon, and they're also planning an additional 15 science satellite missions. That can be everything from Earth observing satellites to space telescopes to gravitational wave observatories. And then between 2035 and 2050, they're planning another 30 space science missions. And so again, more telescopes, more interplanetary probes, landers, rovers, things like that. And it's interesting to sort of hear those numbers, and they sound like gigantic numbers, and yet that's kind of what NASA does. And so you're seeing that China is really planning to boost the number of missions that they send, so that the cadence is very similar to the kinds of exploration that NASA and Europe are doing. And I'll be here until 2050. Continuing to bring you the space news. They're going to make me do this till I'm 90. Jupiter's Great Red Spot jiggles. Astronomers have been tracking this giant anticyclonic storm on Jupiter called the Great Red Spot on and off for about 400 years. And it's one of these features that is so big that you can see it in a backyard telescope. I've seen it. It's very cool. And as I mentioned about Uranus, the Hubble Space Telescope is also doing annual views of Jupiter to measure what things are changing over time, seasons, and of course, the movements of the Great Red Spot. But this year they planned something different. They went and did daily observations of Jupiter using the Hubble Space Telescope. And one of the things that they were interested in was the movements and the changes in size of the Great Red Spot. And one of the really interesting mysteries is that the Great Red Spot is shrinking, and it's dramatically smaller than it was even, say, when the Voyager spacecraft flew by back in the 80s. And so by measuring the Great Red Spot every single day for 90 days, astronomers found something really interesting. The spot is jiggling. So in other words, it's changing in both height and length, and sort of going sort of like, how do you just jiggling? Jiggling is the word, I guess. Yeah. And that was a surprise. And what I love is that in the paper, the researchers said that they have no hydrodynamic explanation. In other words, they don't know why it's jiggling. But by tracking these movements with such a rapid cadence, this will give them a much better insight into how Jupiter's storms interact with each other, how the Great Red Spot is changing over time, and maybe we'll get an explanation for why it's been getting smaller over time, how long it has left to live. Will it live forever? We don't know. Oh, it'd be sad to think of a time when there wasn't a Great Red Spot. And just be like, I remember when. Every week we do a vote on our channel where you tell us what you thought was the best story of the week, and the winner by a landslide was the upcoming Starship Flight 5. And of course, now that everyone's got that out of their system, they're not going to vote for Starship successful landing, are they? Now, we post this new poll into our community tab here on YouTube within about 24 hours of when we do this show. So if you're just randomly scrolling YouTube and you see the poll come up, just give us a second and vote, and it'll keep showing it to you every week. And it's super fun. But the best chance to see the poll is be subscribed to our channel, click on the notifications bell, and then watch a bunch of our videos and find some of the older votes and choose those, and then you'll be locked in and the algorithm will be smiling at you. A possible volcanic exomoon. In 2012, astronomers discovered an exoplanet in the WASP-49 system, so WASP-49b, and it's located 635 light years away. Side note, when I saw this planet, I looked it up in the official exoplanet names for the International Astronomical Union, and it doesn't have a name. And so I couldn't use the name, even though I promised I was going to use the name if I could. So when they have names, I'll use them. Otherwise, WASP-49b. Now, this planet is the size of Jupiter, but it only has about 37% of Jupiter's mass. But what's interesting is in 2017, astronomers detected the presence of sodium as well as other heavier elements like magnesium and iron in the system. And that's kind of weird. It's sort of in a cloud around this giant exoplanet. Now, what's a place in the solar system that is spewing out heavier metals into the environment around a large gas giant? And of course, Io, orbiting around Jupiter. And so the astronomers propose that what we're looking at is the volcanic outburst of an exomoon that is orbiting around this giant gas giant planet, or maybe multiple exomoons. And so they don't see any direct evidence that there is a moon there, but the presence of these chemicals around the planet might be a valuable hint. So this might be a really great way to find candidate targets to then search for exomoons. And if you want to learn more about searching for exomoons, I've got an interview with Dr. David Kipping. He's planning on using James Webb to search for exomoons around a different star system. So check that out. A giant cluster spitting out massive stars. The Large Magellanic Cloud is one of the satellite galaxies orbiting around the Milky Way. And it has a fraction of the mass that the Milky Way does, but it has some star-forming regions that are just colossal in scale. Some of the most massive stars that we know of are located in the Tarantula Nebula in the Large Magellanic Cloud. And thanks to Gaia, astronomers have been able to track the movements of these giant stars in this enormous nebula, specifically in a spot called R136. And what they found is that 55 stars are in the process of being ejected out of the system. And that makes sense. I mean, this nebula is only a few million years old. These stars are only a few million years old, and yet they're having all these close interactions with each other, all of these three-body interactions that will then kick stars out of the cluster. And this makes sense, how you can start with this cloud of gas and dust, then you get a bunch of stars, then they sort of interact with each other, and one by one, they just sort of kick each other out. But these aren't just regular small stars like the kind that the sun grew up with. These are monsters. So as these stars are being kicked out of the nebula, they are going to eventually explode as supernova, turn into black holes or neutron stars, and then continue on this trajectory through the galaxy. And so one really interesting implication of this discovery is to think about what it was like in the very early universe at the time of the age of reionization, when you had the first stars forming out of primordial hydrogen and helium left over from the Big Bang. These stars would have been relatively close together, they would have been interacting with each other, and they would have been kicking each other off on various escape trajectories. They would have been pumping out large amounts of ultraviolet radiation. This might have been one of the things that contributed to the era of reionization in the universe. An update on the Axiom moon spacesuit design. We got new pictures from Axiom Space of their lunar spacesuit design. Now, if you remember the last time they showed us what the spacesuits looked like, they were black, very dark, and they were obscuring really all of the features and functionality that we wanted to understand. There was just people in spacesuits. Well, this time around, we actually see a picture, and they partnered with Prada to produce the design. And then they listed out a bunch of the features that are on the spacesuits. So for example, they've got lights and HD cameras. They've got 4G and LTE communication systems to be able to communicate with each other and back to the base. An in-suit nutrition system, which I guess is just going to be like food that they can eat while they're out on the moon. Biometric monitoring so they can check to see how they're doing. And regenerative carbon dioxide scrubbers. And the plan is for them to have life support for 8 hours. So now we've got a much better idea of what these spacesuits are going to look like. They're going to enter the design review phase in 2025, and the hope is that they will be ready for when the Artemis astronauts go to the moon in 2026, which is just around the corner. Now, you're watching this week's episode of Space Bites, and I am writing my weekly Guide to Space newsletter. This is where we have many more stories that we just don't have time to cover here in video form. For example, how gravitational waves could let us see the first moments after the Big Bang, how an asteroid's movements could reveal a new force in the universe, and how Webb observations shed new light on cosmic reionization. So if you want to get the Guide to Space and get more news on a weekly basis, go to universetoday.com/newsletter to sign up. I write every word, there's no ads, it's completely free. Now I'm going to talk about some planned live stream changes that we're going to be doing, but first I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Barry Lake Roofing, David Gilton, and David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, ScienceWorldRecord.org, Spiderswap.io, Stephen Krasaki, Stephen Fowler, Manley, Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. So as you probably know, I do a live stream every Monday at 5 p.m. Pacific time where we do live questions from the audience, and then that turns into the weekly question show. But I've had feedback from people who live in Europe and in Asia, something to the gist of, by the way, we exist. And I've taken that to heart. And so my plan is to change the schedule of the live streams a bit. So we're probably going to do, and we're sort of working out the details, so you'll see the announcement soon. We're going to do 2 live streams every week that are convenient for North America, for me here on the west coast of Canada. And then we're going to do 1 live stream that is convenient for people in Europe who want to be able to get home from work and then watch the live stream. And then we're going to do 1 that is convenient for people in Asia, Australia. So we're still working out exactly what times are going to be best, but you'll see those changes happen. And of course, if you want to get the announcement for when the live streams are going to be happening, make sure you subscribe to the channel, click on the notifications bell, and when we're about to do a live stream, you'll get a notification that shows up on everything, and you'll be able to come and join us and have that interaction. And if you want to have your question answered almost guaranteed, then I recommend that you sign up for Patreon, and then we do an additional patron-only question show once a month. And in fact, I'm just about to put out the call for patrons. So if you want to sneak in under the wire, go to patreon.com/universetoday, sign up, and then you'll get the call for questions and give me your question. And like I said, it's like 3 hours long, and we try to answer every single question that we get. All right, we'll see you next week.